All right, here we are. This is lab 13, field hockey and some other things related to that. And I'm going to click on this one. So this is similar, uses the PheT website like lab 12. So this is actually used to be lab 16. So don't worry about the dates. The quiz is there. So we're going to look at this one. And I will okay, so we have electric field hockey. So what is it we want to do in this simulation? All right, you can move around charges, and what we're going to do is for this first one, we will, you have the goal, you have this, and we want to put a negative in the goal and a positive there, and then see what happens. Okay. So we can move that. So this one will move once we start playing it. All right. So we got to just like the simulation there. Okay. So what we're going to do is say we then press start. So if you want to do the simulation yourself, you can. I'm just going to show you how it works. And it goes right in the goal. All right. That's the first one. Then you're just going to try and answer the questions and then place two positive charges. So positive charge here and a positive charge there. I'm going to see what happens. So put this back. Put a positive charge here. And now we'll see what happens. So you can start thinking, this is a positive charge. So what do positive charges do? All right. We can reset it. And we can follow its path and notice what it does that way. So it gets pushed by this first one. But then when it gets close to this one, it gets repelled by it and will not go in the goal. So that's the first part. All right, second, going on here, we can go up to different difficulties. You can try different paths. So difficulty one, you don't have to, the questions are only related to primarily this part of what does a path do. If you have a negative charge, what's the path do with a positive charge? And like this one, like the example here is difficulty 1. We have difficulty 1, we have a thing in the way. All right, so we can't just do that. Okay, we have to do something a little more creative. We want to put a goal, we don't want to do that. Because the point is to try and make a range. If you look at this, is try and figure out which charges do you need to get it to get into the path. So I'm just going to try this one. Let's say put a negative here and see what happens. All right, that's not working. Let's try another negative. Let's put this one a little farther away. Reset. Start. Oh, almost. Let's try that. Foo. Then we get a goal. So back on here, just play the game with different levels. You can do, if you want to do level 3, that got goals all over. They got things all over the place. So just play with that, and that's up to you as far as that. So it's just a game as far as that's concerned. Right, next thing, I'm going to get rid of this because we're going to go to the next one, which is balloon simulation. So again, if you bring up the lab, you can bring all these up yourself. And what we have here is click on the balloon. Okay. Show charge differences at the bottom. So you want to do show charge differences, which is now 0. The first thing gets into, we want to what is the charge? Drag the balloon over the sweater and let go. Okay. And the balloon becomes negative, and because it takes negative charges from the sweater, which go onto here. Right? What happens to the sweater after you let go? So if you bring it back, it comes back to the sweater because this is charge positive, this is charge negative, and they attract each other. All right? Bring on a second balloon. Okay, and then bring that over. And now you can see what happens. The next balloon is repelled by the negative charge of the first balloon. All right? So that's the simulation there. You can look at it there. So that's simulation. All right, the next simulation is this thing called jaunt voltage. And basically what you're going to do, and then try that again. And this shows what happens to electricity and discharge. Okay, you can play that one. I'm going to get rid of this. And then next one is simulation Ohm's law. This is similar to what I did in lab 12. So in this case, we are having, all right, use a volter, set the voltage to 5 volts and increase the resistance to 1,000 ohms. Okay. And increase the resistance to 1,000 ohms. All right, then in that case, what is the current? Current voltage is current times resistance. So the current would be the voltage divided by the resistance. So it would be voltage divided by the resistance to get you the current. And that's where we end up at 5 milliamps. Okay. And decrease it to 200 ohms. And there you get, keep the voltage at 5, right? Then the last question is, how does the current change if we decrease the resistance at constant voltage? And that's simulation there. You can play with that as much as you want. All right, then the last, so we'll get rid of that one. Then the last one is Faraday. let's see, what do we want to do? All right, move the compass around, compare this. You can see what the field is around this magnet, right? Notice how it loops from north to south on the north pole of the compass. On the north side of the compass wants a point. So this is how the path of it goes as far as that's concerned. All right, then change the pickup coil. And in this case, we're going to look at induction. All right, what do you need to do to get the magnet to light? If we just put it inside and let it sit there, nothing happens. On the other hand, if we move it, the faster we move it, notice how bright. When we move it very quickly, the light gets very bright. So it's the movement of the magnet that creates the current, what we call induced current in here. So as we go one way, it becomes bright. So this is the principle of a generator. We can actually show a generator. So if we do a generator by letting water run, right? This is basically the same thing we did. A generator causes the electric field to oscillate back and forth, just like regular AC current, which creates the light. So that is lab 12 as far as that's concerned, as far as question is. So you have the quiz related to that. I mean, that's lab 13, I should say. It's listed as lab 12. I'll fix this on the lab. So it shows that it's actually lab 13. Okay, so that's that, and that's the second to last lab of the semester. All right.